SUSE is a global leader in innovative, reliable, secure enterprise-grade open source solutions relied upon by more than 60% of the Fortune 500 to power their mission-critical workloads. They specialize in business-critical Linux, enterprise container management and edge solutions, and collaborate with partners and communities to empower customers to innovate everywhere, from the data center to the cloud to the edge and beyond. SUSE puts the open back in open source, giving customers the agility to tackle innovation challenges today and the freedom to evolve their strategy and solutions tomorrow.
Welcome to Kubernetes Center of Excellence podcast, episode 6. I've got Derrick with me, as usual. Also have Dheeraj from Avesha. Guys, how we doing? Good.
Doing really good.
Awesome. So we're gonna have a pretty meaty conversation today, which I'm pretty excited about. But we need to, Dheeraj, we need to introduce you and Avesha to our listeners. So do you want to give us a quick little bio about you and tell us about Avesha and what you guys are helping customers solve?
Awesome. Thank you, Nick, for having me, and thanks, Derrick. Looking forward to an exciting conversation. So I'm Dheeraj Ravula. I head up customer success, and I'm part of a startup, an innovation startup in the Kubernetes space. And I wear multiple hats, like most people do in a startup company. So I'm actually super excited because there's a little bit of a story of how I joined Avesha. I used to work for Ericsson for about 14 years. I've done probably every role except being a sales guy. And then when I was kind of ready to leave, there's a couple of people I reached out to, and one of them was Raj. Raj and I kind of met at Ericsson as part of some of the R&D work that we did. And when I heard about what Raj was up to, I was super excited. He was basically going to solve the next big thing. Raj has this background where back in '96, he's credited with, along with Cheng, to inventing the first load balancer, Arrowpoint. And now that same team is basically focused on solving the problems with Kubernetes, and actually opportunities with Kubernetes is really how we should think about it, right? Because when we look at Kubernetes, it is the core technology that will help you move your workloads where it makes sense. It kind of makes you vendor neutral in ways that wasn't possible in the past. However, Kubernetes is fairly new. With the introduction, or basically the shift from monoliths to microservices, the complexity of the solutions has gone up, even though the redundancy and the high availability and the performance of the solutions have gone up. What I mean by that is, as engineers, we've all built applications. Right? In monoliths, you kind of tweak one or two things, but when you split that into microservices that make sense, usually you're dealing with a lot more microservices and the interdependencies of the microservices and them independently scaling, right? So it's a complex ecosystem. It delivers values, but it comes with complexity that's hard to manage. And that's the space, right? And then you couple that with workloads becoming more distributed, right? I mean, in the past, most of the workloads were fairly centralized. You kind of build capacity and scale in one or two locations. And we're seeing this trend where you would be deploying a good back-end chunk of your services in redundant, maybe central solutions, right? Either in a data center or big public clouds. But then you start seeing that you actually have to deploy parts of your solutions closer to your customers, closer to where the traffic's coming from, for different reasons, right? Either because you're running very specific loads that have low latency applications, or just responsiveness, better experience. So you start seeing this distributed nature of how these solutions are being deployed. A couple of those two things, right? Kubernetes deployed in a single cluster being more complex than deploying monoliths or semi-monoliths in VM or bare metal solutions. And couple that with being able to distribute your workloads. So the company is very focused on solving those challenges that Kubernetes opportunity creates, right? In terms of how do you connect them efficiently without having to make this a real nightmare in terms of configuration, as well as looking at individual Kubernetes clusters and reducing the cost of operating those clusters. And the third pillar is then when you run each cluster optimally, you're able to connect to your clusters and treat them, even though you're deploying into multiple clusters, and being able to treat them like you're running it in a single large cluster that's spread across different locations. The art of the possible, right? Of now being able to deploy where it makes sense, but also being able to direct the traffic to go to the right location. And right can mean different things, right? Right can mean cost, right can mean latencies, right can mean your carbon footprint. What light can mean latencies not in response time, but latencies to the end customer. Right? Those parameters will change. And being able to kind of put all those three things together to deliver the solutions of the future that are more autonomous, more outcomes driven, rather than kind of trying to meet a certain outcome. So you're flipping how you actually kind of treat these solutions. And that's kind of the space Avesha works in. It is making that super easy, super optimal, automatable, programmable, autonomous. And we're using reinforcement learning to bring that autonomous aspects of being able to kind of let the solution flourish the way it should.
So with reinforced,
I mean, it's a long introduction, but
no, that's good.
I'm super excited about
great.
the company.
So reinforced learning for me is more of a business guy. Feels like it leads to cost optimization in some way. Feels like that might be something you're helping customers out with. Would that be fair?
Absolutely, absolutely. We after about incubating it for over a year, actually 2 years, but it also kind of led from a previous product we did in the medical space. So Avesha has been kind of investing in reinforcement learning for a while now. I mean, ChatGPT is the latest craze. It actually helps us because we don't need to explain what RL is anymore. We used to spend a lot of time explaining RL is not ML. It's a lot more specialized.
But now everybody's a specialist with ChatGPT.
We just say it's like ChatGPT is the same technology, except we are focused on solving Kubernetes problems, right? So,
right.
So we launched last year a product called Smart Scaler, and what that delivers is cost savings on Kubernetes clusters that you run, and we're specifically in this example using reinforcement learning to improve horizontal pod autoscale. When we kind of talk about how Kubernetes is complex, right? I mean, we all have been engineers. We've written code. We've deployed applications. Writing the code, getting it ready for deployment is, I'm sure everyone of us agrees, only half the battle. The other half is really when it's ready for production, fine-tuning it, right? Performance tuning it, making sure it's deployable in production and it can handle the loads or the variation in loads that comes in. And that takes a lot of effort. And usually it takes effort from an expert who understands operations, an expert who understands, in this case, Kubernetes, and also has a good knowledge of the application. And that's not easy to find. And if you find it, the guy's going to be excited about doing it for the first time. Will probably be still interested in doing it the second time. The third time around, he's like, this is too boring. Let me go find something else to do. Yeah. And the reason I kind of tell this long story is it's not meant for humans to do that kind of stuff. It's to kind of parse through logs and kind of go through huge amounts of data. It's tiring. It's exciting, but definitely tiring. You wouldn't want to do that for more than 2 to 3 times. So we took that problem set because that problem set is huge. If you've been to any company that has large production workloads, especially ones that have a variable load, right? It's not like the same amount of traffic coming in all the time. What's happening is Kubernetes has a solution called horizontal pod autoscaling. Unfortunately, it's reactive, meaning when the traffic goes up, it'll try to bring up more pods. If you're lucky, it comes up fast. But in the meantime, you're going to have a lot of failures. If you're unlucky, you've already bin packed your node. You need a new node. That takes minutes. That means you're basically not able to handle the spike for another few minutes, and you're going to get a lot of failures. And how do humans usually respond to that? We don't want to lose my job because I was failing it, so I'm going to over-provision. And what we're noticing is that over-provisioning is a huge problem. utilizations for resources you paid in the low digits, like sometimes 10 to 20%, 30%, 40% is norms. And if it's in the data center, even more. It's like you shouldn't be surprised if there's Kubernetes clusters that are using between 10 and 20% of the capacity they have. Because most people will say, I want this much, and they actually need this much. But nobody wants to take the risk because it's a very reactive thing. So to meet SLAs, over-provisioning has become a very common practice. So we use reinforcement learning, so you don't have to do that. And what we do is we take all the historical data, we look at patterns. The first step we actually do is kind of understand what is the pod capacity, like for an individual service that constitute the application. And in the same process, we create an application profile. So we understand how the application scales as the traffic goes up, which is usually never linear. And we take that data and then we feed it to the reinforcement learning, where we create and simulate millions of data points and train a model that is creating an outcome-based model, right? Basically, we're telling the model, in the examples that we usually show, we're telling them, operate the services to deliver a certain SLA. In our case, it's usually response times less than 2 seconds or some number of seconds, and having success rates of 99% or more. Right? That's the outcome we train for. And then with the model, when it converges and you actually use that inferencing model against a live cluster, it's able to predict traffic and manage your SLA to that less than 1% error rates and a certain response times. Now, this is an example. You can also feed it custom metrics and say, sometimes you'll have false positives or false negatives, like success rate is high, but overall the system's not doing well. So you can do custom metrics also to kind of train for outcomes, and then you let that manage your cluster. And the beauty of it is it's delivering you low costs. This is an instant gratification of lowered costs, but it's also helping you understand your applications better with every release or a change in environment, or if you've deployed it on different nodes. So that value proposition of instant savings on costs, and then later on better insights to your own application, will increase the rate at which you can deliver features into production. So, sorry, I think I'm so excited I might not pause unless you ask me to. So.
Do you mind if I interject, Nick?
Dude, go ahead.
Okay, so I'm gonna, the audience knows me at this point. You guys know my background. I've been using Kubernetes for 8 years. The biggest thing that I will start off before I dig into this is that I have fully drank the Kool-Aid in terms of Avesha's stack. So, and what I mean by that is I've used it, I talk to it, I think about it all the time because of problems that it solves for. That although Dheeraj is talking about a lot of these things, he's almost skirting past smaller scale problems that become bigger scale challenges that people don't think about until they're really, really in the weeds dealing with this stuff. An example of that, if you're trying to deploy something into Kubernetes, there's a concept called requests and limits that you need to set on every workload in an environment. You don't have to technically, but you would be idiotic for the most part not to, for a bunch of different reasons. The biggest of which, you're not putting boundaries on consumption. So you can talk about that from a cost angle. The way that I talk about it, though, in some retrospects, yes, there's a cost perspective of this. If let's just say you're on premise and you can't, for some reason, auto scale your nodes. One of the biggest things you have to do is try and fit your workloads into your cluster. And if you don't put requests and limits on anything, what ultimately ends up happening is the cluster itself becomes over-provisioned as workloads start to get interacted with. And then you have things crashing all the time. So as a response to this, what people usually do is they set those requests and limits based off of a finger-in-the-wind judgment call. When it was in a VM, it was running Tomcat before, and it was given 600, megabytes of memory and 2 cores. Let's give it the same thing here for the request, and the limit will give it a little bit of buffer room. Well, the reality is the way something runs in a VM is very different than the way it runs in a container for a lot of different reasons, most of which is because when you give a request to a container, it's not reserving an actual core. if you do like, 1,000 millicores. What you're reserving is CPU time, which affects the way the process actually operates. People don't usually know this until they find out when they're using it, and then things start falling on their face. Then it becomes a long game of constantly trying to tune and figure out what's enough of a tuning to make this thing not collapse on itself, perform properly, right? Without wasting resources in my environment. The answer to that in totality was the vertical pod autoscaler. But the vertical pod autoscaler, for anyone who's used it, essentially just spits out some numbers that it thinks is the best guess judgment based on metrics that it's seen that's been running, what it maybe should be. What Avesha's Smart Scaler does, this is just one of the things that they have in their stack. What the Smart Scaler does, yes, it acts like a horizontal pod autoscaler, including if you're using Kube Slice across multiple clusters. So if you have two clusters and one is cheaper to run because it's in Azure and the resources are cheaper, and the other one's in AWS and the resources are cheaper, it will scale across those clusters if you want it to, based on cost. But the bigger thing that's it's glazed over, it's not even mentioned, is they right-size tune the resource requests and limits based on failure rate of the environment as they study it over time using their reinforced learning model. That takes so much work out of the game of managing your environment. I can tell you from consulting firsthand how long people spend just trying to tune their workloads so they don't overrun the provisioned resources they have. So that's like a huge thing that it's just like almost overshadowed, but it's so important to mention in my opinion. Anyways, now I'm getting overly excited. But
No, that's actually, that reminded me of my days. Unfortunately, it was usually late in the evenings spent doing that kind of stuff.
yeah.
That's usually what most engineers do, is you do your day job and in the evening you kind of trying to tune what you already put out there.
Right.
And that's a lot of stress, right? I mean, it's not just stress, but it induces a lot of concern and anxiety of putting new features out there.
Absolutely. Absolutely. And
so
basically, go ahead, Nick. Go ahead.
So this has been my experience around optimizing cost. Like I had a customer for years who did everything in AWS and all types of services, and they just couldn't quite get a handle on what they were provisioning and spending. As Derek wipes his camera down,
I'm trying to make it refocus. I don't know why
it's all very foggy. It's like a sauna.
No, you scoop back and scoop forward. Oh, look, it came back! Yay!
Hey, it's better.
You have an intelligent camera. The problem is it's thinking it's more intelligent than you. So it needs to stop doing that.
Yeah.
So like my customer, they would go, we need a tool so that we can be optimized around our consumption of cloud resources. So we used a third-party tool. I won't talk about them, but it's one people have heard of. And it would ingest all that information. It would put it into some like graphs, but it wasn't actionable.
Right.
And I think that's the thing we've been missing around this whole cloud native landscape is like we needed, the learning to catch up, to create actions, to actually help people run workloads in an optimized way.
Right.
Because, to the point earlier, you just over provision. I got to have space. Well, that's the same problem we had in the data center. We got to buy the biggest machine we can just in case we have spikes. And then, and then it was like, well, if you move to the cloud, you can right size all these workloads and you can pick what you want to do and you can migrate them with ease. And none of that's true. It's nobody has time for that. Right. So
nobody has time for it. Yeah.
So the fact that we're right, mostly the pay or the expertise. And I think that's a big thing in the marketplace that's going to be challenging. Lots of people can stand up a workload in a VM, or maybe, put something in Kubernetes, but is it the right way? Who knows?
Yeah.
Who knows? Only time tells, and usually tells a bad story, right?
Right.
I think it's always arguable what's considered right, because right has definitely changed over time. Like, even if we look back to the way Kubernetes used to be implemented, it was all singular clusters, and the way people used to talk about was DR and HA was on the cluster, which is the stupidest thing to think about in retrospect years later, right? But at the time, it made sense because you're like, well, if a workload fails, There's other nodes running. It'll just cascade it over. But nobody was talking about what happens if the cluster fails? What if the API just caves in on itself, right? Which is something else technically you solve for. So like I glanced over it myself before when I was talking about the scaling across clusters. And you even glanced over it when we talked about, what Avesha's main purpose was in terms of when it first came out and what Raj was thinking when they started putting these pieces together. The big thing, and for audience members who are listening who don't know, the open source piece of technology that their original product was based on, they built and donated to CNCF. It's called KubeSlice. What KubeSlice does is it allows you to take two or multiple clusters and link them together from a network topology perspective. Now, with that being said, you can also slice those clusters up in different unique forms and fashions. You can have 4 clusters look like 2 clusters in the sense that a portion of all 4 of those clusters make up one cluster, and a portion of the other, another portion of those other 4 clusters make up another cluster. And where that becomes really rich and powerful is, yes, you can do things like get things deployed in 2 different clusters to talk to each other. But it also allows you to do service discovery across 2 clusters, which everyone wants to do, and no one is actually doing it right now unless you're specifically in Istio and using glue mesh and you have both clusters talking to each other with glue mesh. But KubeSlice don't care. Pick your service mesh. Don't use a service mesh. Link the 2 clusters together from a network perspective over encrypted tunnels and let them self-discover each other. And that just gives the horizontal pod autoscaler to work across that given plane that it's been provided.
No,
I'm tooting your own horn at this point.
No, I think you described it so well. So you call the word global clusters, superclusters, and the concept is exactly what Derrick was talking about, right? Is why would you deploy in a single cluster and kind of paint yourself into the corner? Why wouldn't you deploy across multiple clusters that are spread regionally or globally? And then be able to shard it. Right? I mean, from the data, I'm kind of taking that term from the database space, but it's a shard, right? You create a shard that goes across your clusters, and you can designate that for an application or a team, right? And then they have what to them would appear like a single cluster, but is actually a shard from multiple clusters deployed where it makes sense, right? So if you think of a large enterprise or a SaaS company that has what I would call shared infrastructure, right? And the infrastructure is clusters deployed in multiple locations where they have customers. And then for every application or team, being able to pick one or more of those clusters and make a shard where they can deploy. So fundamentally, you've kind of shifted the problem from operating clusters for each team to operating your infrastructure that has shared clusters. And then each team can basically have a redundant, right, a DR solution that spans multiple clusters on the where you need it, right? So from an operational perspective, you're managing an infrastructure layer, and the applications are basically coming and choosing where they want to deploy. And you can do that programmatically and dynamically, right? Meaning today you might only need it in 3 clusters. Tomorrow you might have to do for 3 days based on some new load that you're expecting, additional 3 more clusters that are part of that shard.
Right.
And you're able to do that programmatically, dynamically. And we're seeing a lot of use cases in database redundancy being implemented using the KubeSlice in the telco space, where you typically deploy solutions across large database data center clusters, but large number of smaller edge clusters, and opportunistically also using the cloud to deploy solutions into.
Sure.
And being able to do that in a very programmatic, automated, autonomous fashion. The power actually is not being able to do it, but being able to do it in a very programmatic, automated
Right.
fashion.
Right.
And like let's say you had an example where you're expecting a surge, let's say Super Bowl as an event, right? And you know that if you're going to stick to a 3-4 clusters deployed across the country, it's not usually a viable option. And we've seen a lot of these high-profile events have issues because they're not able to scale more dynamically and respond to traffic from different parts of the region. you can now kind of do that very programmatically and utilize compute where it's available. Right? You can leverage the edge, you can leverage the regional, global, public clouds, or large data centers. Right? So.
Dheeraj, I know we've talked about ingresses. The biggest thing, if I was listening right now, and someone went, okay, you can horizontal pod auto scale and you're slicing up kube clusters. How do you handle ingress? Now, I know what your product has an answer for that, the global load balancer, but I don't understand because I haven't worked with it like at all yet, how the underpinnings of that actually functionally work other than it auto routes traffic to where it's supposed to go and what cluster it's supposed to go. Can you talk to that a little bit?
Yeah, so you're actually talking about the third leg of the stool. That's
right.
at least how I describe it. Right?
Yeah.
You have the globally connected fabric, which lets you deploy where it makes sense and behave like you're actually deploying into a single cluster.
Right.
You take away the complexities of, if you didn't use kubeslice, you would have to set up your ingress rules, your gateway. You'll have to put it through a firewall, go through a security audit. Right. So it can talk from one cluster to the other. We take that away. We kind of just do east-west native layer 3 traffic, which means you don't need to even force it through HTTP. Like if you have a application that needs SMTP, it'll flow through. You don't have to make any change to the application.
Right.
Now we've kind of used RL to run these clusters at the lowest cost possible, because we're kind of doing HB at a much better optimization level. When you connect those two things, now you have the means to run the workload where it makes sense, but now you also need to kind of work out how do you direct the traffic to go to the right location.
Right.
And that's where we kind of have the third product, which is our global director. Right. Its role is to, since all of these clusters are connected to the kubeslice, now we are aware of the characteristics of the resources available in each of these clusters. And typically, load balancing happens at its most common way is round robin. Right? If you say I have services available in 10 different places and these are IPs, then you have a load balancer that basically kind of rotates through them and make sure that they're getting equal traffic. But with where the industry is leading, not every location is equal.
Right.
I mean, the parameters change. I mean, the size of the location could be small, especially edges are smaller than regional centers versus data center. And then the characteristics of that location is like in terms of latencies, in terms of availability of resource at that given point of time. What is the carbon footprint? This is actually a hot topic these days, sustainable computing. What's the carbon footprint of some of these locations? And you're able to say, I want to do X, Y, and Z, and then let the traffic get directed to the right location based on cost, based on low latencies or carbon footprint. And we're able to do it because as a slice, you're now aware of all the different clusters and the parameters that go into those clusters. So as one cluster gets more load, you can find an optimal location that can take the same traffic and direct it to that one. So that's kind of where we use reinforcement learning to do that too, right? We are learning from network behaviors, response times from these applications, latency numbers from the end user devices, right? So you put all that data points, and then you're intelligently able to tell where that user should go at that given point of time based on resource availability, or because even though the lowest latency location might be right next to you, what if it didn't have the capacity to handle your request? Right? You shouldn't be sending that traffic there. So that's the third leg of the stool, right? And you put those three things together is really how we're attacking this autonomous infrastructure problem, is being able to program and let the outcomes decide how the solution kind of sends the traffic as well as brings up new resources in locations where there's availability. Did that make sense?
Yeah. So when the thing that I want to know though is like in terms of that, because that completely makes sense to me. But like, do you guys deploy like a load balancer inside? Let's just say someone's AWS or on premise. Are you integrating with like their existing load balancer, like F5 or whatever? And then what's the behind the scenes of that look like? You're like, oh, we have this entry point into the kubeslice that is globally located that routes traffic to the different ingresses of the different Kubernetes clusters? Like topology wise, what does that interaction look like?
So that's a very good question because there's a little bit of details that go into this.
Yeah.
So what Avesha is, actually, let's talk about what Avesha is not. We're not a global load balancer.
Okay.
We're not a DNS service.
Okay.
But we bring intelligence to those things.
Okay.
So most of the global load balancing happens through a DNS service, and the DNS service that aware of where all the endpoints are.
Okay.
And happens in a very simplistic fashion. So what Avesha is doing is using reinforcement learning to kind of inject intelligence into that decision-making process. So when you use a DNS, it resolves to the right location.
Mm.
So we do that assist, an RL assist, to kind of tell at that given point of time what is the right location to send that traffic.
So
based on different parameters.
Do you have kind of like your own name server that your system is talking to, and then someone's DNS like GoDaddy or Route 53 talks to your name server, which is being programmatically modified based on routing, and that's telling them go to this ingress or go to that ingress or go to that ingress, more or less? Is that what's happening?
It is at a high level. That's what's happening. So we do depend on functionality of some of these DNS providers. Some of them are capable of doing more. Some are capable of doing less.
Okay.
So for the capability we need is to be able to tell which one is a preferred location, right, in the list of available locations.
Gotcha.
So we basically integrate into that API call that says, for this service at this given point of time, and since we're using RL, we're predicting.
Right.
So I mean, if you look at how DNSs work, right, it's based on a lot of caching that happens because you don't want to hit the DNS server every time.
Right.
So we can project forward using reinforcement learning. So we have enough time where the cache is actually more accurate.
Interesting.
At that given point of time. So yeah, it's a little bit of a complex problem because of all
it's interesting
that happens.
Yeah.
And the power comes in being able to predict, because you're kind of reading into all these different data sets and you create inferencing models that are able to take those data sets and be able to predict forward.
Got it.
Is there a sweet spot for a customer type or industry where Avesha knows walking in the door, we're going to make a big impact here? Please say government. I'm kidding. Not really.
I mean, anybody who's large solutions, right? I mean, that's usually the best customer is somebody who's deployed at scale is an ideal customer.
Got it.
Somebody who's deployed lots of clusters or large clusters, because when you're doing large clusters, you have a limited expertise that's managing all these clusters, or maybe not managing these clusters, right? It could be one of those.
Right.
So that's usually typically an ideal candidate, somebody who has distributed compute, somebody who has the DR solutions that need high availability, right, and need SLAs.
Well, and that's kind of what I was thinking, right? And correct me if I'm wrong, Dheeraj. I feel like probably a prime customer would be anyone who's looking for at least a hot, warm HA type thing, where you might have, even if it's two clusters in the same cloud, right? Mm-hmm. You guys have the ability to, if this cluster goes down, it's obviously the smart scaler is going to scale it up in that other cluster automatically. And although it's not immediately there, it's there in seconds because it doesn't take much for the other workload to spin up. Now, granted, we're talking about ephemeral workloads right now. There's ways to solve for the storage challenge. But what I'm talking about specifically for this, though, is like the hot warm is it's almost hot. It's like 98% to 99% of the way there. And in some ways, it could be all the way there. I guess if you tell me if I'm wrong, again, can the smart scaler, can you tell it every time it needs to scale, there needs to be half of the distribution needs to be in this half of the cube slice and another half has to be in this half? So there's always stuff scaled across both.
So it's the third leg of the stool that decides where the traffic's being directed.
Okay.
Based on characteristics you define for that cluster. And then smart scaler is kind of working on both the clusters that are connected by cube slice. But since they're connected, you're aware of what's happening in those clusters. Usually you don't get a drop in traffic in a cluster, right? You start seeing deterioration of resources or response times, and you're able to predict that cluster is going to go down.
Sure,
So you have enough time to actually kind of direct it. It usually does not happen where, I mean, there's situations where it can go down like without any hints, but most often that's usually not the case. Right? They get overloaded as they deteriorate to the point that they become unavailable.
I'm kind of thinking like let's say you're in AWS and US East 1 goes out, right? Like, you know what I mean? Like in those,
how many of those times is it predictable? Meaning, if you're actually kind of, does it deteriorate and go down, or does it just go down outright?
And when it's happened, it just happens, right? Like
it happens. In that case, I think the kube slice would be aware that the other side is gone, and you would not be getting any recommendations from the other side for what to, like how much traffic to send there. So it obviously gets kind of taken out of the loop. And the traffic naturally just goes to the other cluster that's still available.
Right.
So those are the mechanisms that kind of all kind of come together. However, these are not products that depend on each other. Right? You can deploy them independent of each other, and they still work and create value for customers by themselves. Like the smart scaler, if you have any large cluster with a huge spend, you're more likely going to save quite a bit of substantial amount of money by applying smart scaler to it. But then if you can kind of overlay the kube slice, if you have a distributed workload, and if you are interested in directing the traffic as well, then the third product comes into it.
So you can start small.
You can start where it makes sense for each of the customers. Right? I mean, if the customer's looking for cost savings, and that's their top priority, we meet a lot of those customers. Like right now, they are only focused on cost savings. And this becomes an interesting conversation for that.
I mean, if it's me, like kube slice almost always makes sense. However, what does always make sense is the smart scaler. Just even if you weren't like using it in your mind, like, oh, I want to scale across clusters. Even if you weren't going to do it for that reason, just for the request and limit setting, like setting appropriately and intelligently understanding what it should be set at, like if you don't use this, it is not a straightforward thing to do at all. You're looking at graphs over time, trying to interpret like how much something was overconsumed or underconsumed, how much throttling Kubernetes was doing to something. Like it is more of an art almost than it is a science in the terms of viewing it right with your own human eye. Whereas if you have something looking at it constantly, that's constantly interpreting what's happening and making slight modifications to dial it in, that's way better than any human is going to be able to do to get your requests and limits appropriate. And everybody kind of knows that.
When you're talking, the visual that came to my mind is all the bonding that happened.
Yeah.
Over looking at lots of graphs and data points every day. This used to be every morning. And I'm going, man, we might make it a little boring. I'm just kidding.
But you can call it boring. But I was just saying, it sounds like busy work where you're being productive for how efficiently the business runs, but you're not creating new things for the business, right?
No, I was just being.
That's the way that I look at it. Yeah, I hear you.
I was thinking about
some of the
deep points that I made when we were basically fighting fires. It was fun for the first day, by the way. I mean, I'm not saying it's fun from customers not being happy,
right?
But you get that intense feeling of, oh, I know how to solve this problem. But that doesn't last long. Right? That's the real problem is you're kind of letting RL do all the grunt work so you can focus on creating the value for the customers. And I was trying to be funny. I don't think I really worked on it. But
self-fun. I'm just kidding. I'm kidding.
Well, guys, we're up against it. This went so fast. We got deep talking about the tech, and here we are. So
that's what happens when people are excited about the stuff they're looking
That's right.
at. So
that's right. It just goes off. So we might have to do a follow-up.
Part 2.
Yeah, part 2.
We can actually talk about use cases without probably naming the customers. We can still talk about use cases where the conversation starts very simple, but what we're noticing is the conversations move fast because it's resonating. It's the pain point is very real right now.
No, that'd be great. I mean, we like to talk about customer stories, so even if they're nameless, Acme customer A, that's fine. I think it gives our listeners a
frame of reference for what's possible. And in the Kubernetes space, I think we all need a little bit of that. So that's really exciting.
Can I just say, by the way,
you got to be quick. You got to be quick. You got to go, Derrick.
I love, Dheeraj, that Avesha literally says we use reinforced learning for smart scaler rather than we use artificial intelligence, which is like such a broad bucket. Or they'll say we use data science, and you're like, okay, what does that actually mean? And they never tell you, which you're like, are you actually doing anything? Or is there like a guy in the back that's like, he's artificially intelligent because he's not actually intelligent. You know what I mean?
Yeah. Well, words mean things. That's something we've said a few times on the podcast. Sure. It's one of my favorite things to say. Like, just tell me what it is, right? Yeah. So that's great.
No,
that's a good point.
ChatGPT, we can use RL without having to fully explain it.
You're like, we're just talking to Bing now.
Even my mom knows what ChatGPT is, which is hilarious. Weird. So,
God.
Well, guys, thank you so much for the time. I think it was a great talk, and I think we'll do a follow-up around some use cases in the near future. So,
for sure,
listeners,
thank you so much
for
having me.
Yeah, absolutely. Thanks for coming on.
Yeah, man.
All right, see you guys.
Thanks a lot.
Bye.
Dynatrace exists to make the world's software work perfectly. Their unified software intelligence platform combines broad and deep observability and continuous runtime application security with the most advanced AI ops to provide answers and intelligent automation from data at an enormous scale. This enables innovators to modernize and automate cloud operations, deliver software faster and more securely, and ensure flawless digital experiences. That is why the world's largest organizations trust Dynatrace to accelerate digital transformation. Shadowsoft, a leading Kubernetes systems integrator, is excited to announce the launch of Kubernetes Academy, a free online education platform to teach the skills needed to become proficient in Kubernetes. The Shadowsoft Kubernetes Academy platform offers courses and resources for learners of all levels, from beginners just starting to learn about containerization to experienced professionals looking to dive deeper into the intricacies of Kubernetes. Kubernetes Academy is now available at academy.shadowsoft.com. Start learning today and join the thousands of IT professionals already on the path to becoming Kubernetes experts. Shadowsoft helps you make optimal possible.